Calculate the molar mass of sulfuric acid. Whenever we calculate the molar mass, first thing that we need to do is list out everybody that is present. So we have hydrogen, sulfur, and oxygen. Then we will count to see how many of each we have. Subscripts are how we do that. The subscript for hydrogen is 2, so I have 2 hydrogens. Subscript for sulfur is invisible, which means it's a 1. Oxygen has a subscript of 4, and then I will reference the periodic table to determine what mass everything is. Hydrogen on the periodic table has a mass of 1.008. 2 times 1.008 is 2.016. Sulfur has a mass of 32.066. 1 times anything is itself, so the mass contributed by sulfur is 32.066. Oxygen has a mass of 15.999. Four times 15.999 gives me 63.996. When I add all of these up, I get the number 98.078. Molar mass has the unit grams per mole, and I'm going to write the molar mass as a conversion factor so that I can use that later. Since it's a conversion factor, I do need it flipped. Using the balanced chemical equation, I have 1 sulfuric acid being added to 2 sodium hydroxides, producing 1 sodium sulfate and 2 hydrogen dioxides, dihydrogen monoxides, water. Create the multimole ratios between sulfuric acid and sodium sulfate. I'm going to identify the molecules of interest. They're going to be stated in the problem, and I will also emphasize them in the equation. So we have sulfuric acid and sodium sulfate. Then I will visually connect those two. Then I will take the coefficients from each and produce a multimole ratio. The coefficient in front of sulfuric acid is invisible, which makes that a 1. I will insert the word mole. There is 1 mole of sulfuric acid for every coefficient in front of sodium sulfate is also 1. 1 mole of sodium sulfate. Since this is a conversion factor, I will flip the fraction. Moles of sodium sulfate were on the bottom, so in my second iteration, I will have it on the top. If 9.34, you'll notice that the 9.34 is in brackets. This is because my number can be different than yours. It doesn't necessarily mean that your problem is going to be solved in a different way. Your problem will be solved in the exact same way, excluding the number. If 9.34 grams of sulfuric acid reacts, how many moles of water are produced? Question word is how many. It's attached to the unit moles. Moles is attached to the compound water. is produced as my equal sign, and the number given in the problem is 9.34 grams of sulfuric acid. I'll go ahead and set up my dimensional analysis train tracks. Currently, I am in the unit grams of sulfuric acid, which means that I need the molar mass of sulfuric acid. I have already calculated the molar mass of sulfuric acid, so now I only need to pick between the two conversion factors. I currently have grams of sulfuric acid in the numerator, so that means I need to choose the version of the conversion factor that has grams of sulfuric acid in the denominator. That will be this blue version. So that will be what I plug in. Grams of sulfuric acid will cancel as they appear in the numerator and in the denominator, leaving me exclusively with moles of sulfuric acid. That is not the unit that I wanted. I wanted moles of water, so that means that I need to go ahead and find the multimole ratio between water and sulfuric acid. That is not the multimole ratio that I found in the previous problem. So I can go ahead and re-establish my multimole ratio. I can use the same balanced equation. I'll differentiate it with a different color. Coefficient in front of sulfuric acid is 1. So for every 1 mole of sulfuric acid, there is coefficient in front of water, 2 moles of water. And I'll flip that ratio. For every 2 moles of water, there is 1 mole of sulfuric acid. Now that I have both versions of that conversion factor, I can go ahead and choose the one that will allow me to cancel out moles of sulfuric acid. Moles of sulfuric acid are currently in the numerator, which means I need to choose the version that has sulfuric acid in the denominator. That will be that red version. Moles of sulfuric acid will cancel, and that will leave me with moles of water as the only unit left in my math, which is going to be the unit that I said that I wanted, so I can go ahead and plug everything in. So I will multiply everything in the numerator, so 9.34 times 1 times 2, and I will be dividing by everything in the denominator, so 98.078 and 1. That will leave me with the number 0.19046065. Blend is asking for 2 decimal places. 0 does not make me round up, so that would make my final boxed answer 0.19. Only English left in my math, the unit that I said that I wanted, moles of water. Calculate the molar mass of iron 3 oxide. I'm going to list everybody that's present. That would be oxygen and iron. I will check subscripts to find the amount of each element present. Iron has a subscript of 2, so that means I have 2 irons. Iron's mass is 55.845. Two times 55.845 is 111.69. Oxygen subscript is a 3, so that means I have 3 oxygens. Each oxygen has a mass of 15.999. 3 times 15.999 gives me 47.997. When I add these up, I am left with 159.687 grams of iron 3 oxide for every 1 mole of iron 3 oxide. Since this is a conversion factor that may be used later, I'm going to go ahead and flip the fraction. 1 mole of iron 3 oxide for every 159.687 grams of iron 3 oxide. Using the balanced equation where I have 4 irons coming in contact with 3 oxygens forming 2 iron 3 oxides, create the multimole ratio between oxygen and iron 3 oxide. So I will identify the molecules of interest. They will appear in the problem, and then I will underline and connect them in the balanced equation. Then I will go ahead and create the multimole ratio by referencing the coefficients in front of each molecule. Coefficient in front of oxygen is 3. I will insert the word mole and then write the formula, O2. Coefficient in front of iron 3 oxide is 2. Insert the word mole, iron 3 oxide. This states for every 3 moles of oxygen, there are 2 moles of iron 3 oxide. I'm going to go ahead and flip this fraction, which is not actually a fraction, it is a ratio, and state for every 2 moles of iron 3 oxide, I have 3 moles of oxygen. How many moles of oxygen are needed to produce 1.1 grams of iron 3 oxide? You'll notice that my number is in brackets. This is because my number may be different than yours. However, how I solve this problem will be the exact same steps that you will need to follow using your own numbers. I will now begin to translate the English problem into math. How many will turn into X moles, compound that was attached to that unit, oxygen, are needed to produce is my equals. 1.1 is my number given in the problem, grams of iron 3 oxide. And I'll go ahead and set up my train tracks. Currently I am in grams of iron 3 oxide. To get out of grams, which is a mass, I need the molar mass of iron 3 oxide. I have already calculated that in a previous step. Now I just need to select the version of the conversion factor that allows me to cancel out grams of iron 3 oxide. Iron 3 oxide is currently in the numerator, so that means I need to choose the version that has grams of iron 3 oxide in the denominator. That will be that red version, so that is what I will plug in here. Grams of iron 3 oxide will cancel, leaving me with moles of iron 3 oxide. However, this is not the unit that I wanted. I wanted moles of oxygen, so that means I need to use a multimole ratio, which I have already determined in a previous problem, so that is what I will reference. I currently have moles of iron 3 oxide in the numerator, and so I need to choose the version of the conversion factor that has moles of iron 3 oxide in the denominator, such that it will cancel. That is my blue version, so that is what I will plug in. Moles of iron 3 oxide being in the numerator and in the denominator means that it will cancel, leaving me with the only English left in my math being moles of oxygen. This is the unit that I said that I wanted, so I can go ahead and start solving my problem. So I will multiply all things in the numerator, so 1.1 times 1 times 3, and I will be dividing by everything in the denominator, so 159.687 and 2. That will give me the number 0.010332713. And on blend, I am asking for 2 decimal places, so 1, 2. This one is the last number that I care about. 0 does not make me round up, so my final boxed answer would be 0.01, only English left in my math, moles of oxygen. Calculate the molar mass of carbon dioxide. First up, I will need to list out everybody that is present. So I have carbon and I have oxygen. Next, I will reference the subscripts to determine how many of each I have. Carbon has an invisible subscript, which would make it 1. Carbon's mass from the periodic table is 12.011. 1 times anything will give you that thing, so 1 times 12.011 will give me 12.011. Oxygen subscript is 2, so 2 times, and the mass from the periodic table is 15.999. Two times 15.999 will give you 31.998. When we add these together, we will get the number 44.009. This number has the unit for molar mass, which is grams, whatever that compound is, CO2, per 1 mole of that compound. Since this is a potential conversion factor, I'm going to go ahead and I'm going to flip the conversion. For every 1 mole of CO2, I have 44.009 grams of CO2. Using the balanced equation, 2 dicarbons, hexahydride, and 7 oxygens, I am going to produce 4 carbon dioxides and 6 waters, 6 dihydrogen monoxides. Create the multimole ratio between water, H2O, and carbon dioxide. I will go ahead and emphasize the conversion, or the molecules that are of interest, which is water and carbon dioxide. These will be stated in the problem, and then I will underline and visually connect them in the balanced equation. Next, I will complete the mole-to-mole ratio using the coefficients in front of each. The coefficient in front of carbon dioxide is 4, so I will write 4. I will insert the word mole and then carbon dioxide. So I will have 4 moles of carbon dioxide for every coefficient in front of water, 6. Insert the word mole of water, H2O. Since this is a potential conversion factor, I'm going to go ahead and flip it and state for every 6 moles of water, there are 4 moles of carbon dioxide. How many moles of water are produced if 2.56 grams of carbon dioxide are produced? I'm going to go ahead and translate this English problem into math. How many moles will turn into X moles, and then compound attached to that unit, water, are produced if is my equal sign. And 2.56, you'll notice, is in brackets. This is because my number may be different than yours. However, the steps that I'm going to take to solve this problem will be the same regardless of the number. Number given in the problem, 2.56, unit attached, grams, and then compound attached to that unit, carbon dioxide. I'll go ahead and set up my dimensional analysis train track. I am currently in grams of carbon dioxide. I need to get out of grams of carbon dioxide, so I need to use the molar mass of carbon dioxide. The molar mass of carbon dioxide was already determined in a previous problem. Now I just need to pick the version of the conversion factor that allows me to cancel out grams of carbon dioxide. Since grams of carbon dioxide is currently in the numerator, I need to choose the version of the conversion factor that has grams of carbon dioxide in the denominator. That will be this red version here. Grams of carbon dioxide appearing in both the numerator and the denominator means that it will cancel. Now I am currently in moles of carbon dioxide. However, I wanted moles of water, so that means that I am not done with my problem and I need to continue on. I need to choose the multimole ratio that allows me to cancel moles of carbon dioxide. Since moles of carbon dioxide is currently in the numerator, I need to choose the version of the conversion factor that has moles of carbon dioxide in the denominator. That is this red version here, so that is what I will plug in. Moles of carbon dioxide will cancel, leaving you exclusively with moles of water. This is the unit that I said that I wanted, so that means that I can go ahead and plug in my problem. So I will be multiplying everything that appears in the numerator, so 2.56 times 1 times 6, and I will be dividing by everything in the denominator, so 44.009 and 4. The number that I got out of the calculator was 0.087254888. I am asking for 2 decimal places on blend. 1, 2. Look over to see if you need to round up. 7 does in fact make you round up. Turning that number into 0.09, only English left in my math, moles of water as my final boxed answer.